Okay, here we go. So lesson 1.4. So like I said, this lesson is talking about some vocab terms and then some graphs. And this will be kind of the biggest part of the quiz on Friday. All right, so we're going to talk about variables today and kind of identifying variables and data sets. Okay, so your first two vocab terms, pretty straightforward, pretty easy. The first one is called a univariate data set. And a univariate data set, if you kind of break down that word, una or uni means one, like unicycle. Variate means variable. So it just means it's a data set that has one variable. And that's it. All right, so a data set consisting of observations on a single variable. So we actually collected a univariate data set already in this class when I asked you guys about your screen time, right? Every single person gave me one number. So that's how you know it's a univariate data set, because every person responds with just one number. Your second vocab term is bivariate data set. You can probably guess that bivariate data set means that there are two characteristics or variables for each observation. So this is like if I asked you guys to give me your height and weight, and we wanted to see if there's a relationship there. That would be considered a bivariate data set because you're asking two questions for every person. Going back to our example yesterday, do blondes really have more fun? This could also be a bivariate data set because we're asking hair color and how much fun. So that would be a bivariate data set. All right. So any questions on our first two vocab terms? All right, moving right along. A variable, since we're talking about all these variables, is just a characteristic whose value may change from one individual to another. All right, so like we said before, everybody's a little different. So if I asked you your height, everybody would give me a different, value. So that's why it's called a variable. It changes depending on who you talk to. All right, now speaking of variables, there's two different types of variables we're going to talk about in this class. There's categorical. For example, hair color is categorical. And there's also numerical, which we sometimes say quantitative, we sometimes say numerical. Those are interchangeable. Those mean the same thing. So like how many hours of fun would be a quantitative or numerical variable. So categorical is just, like categories. Numerical, it's, you usually get like a number or you're measuring something, okay? So we're gonna go ahead and we're going to practice identifying when a variable is categorical and when it's numerical. All right, so here's some examples. All right, so I want you guys to think about whether or not it's a categorical or numerical variable, okay? Categorical or numerical variable. So the first one is age. Okay, so think about, is that categorical or numerical? And feel free to unmute yourself if you think you got it and tell me what you think it is.
Numerical.
Good, yes, numerical. All right, so you're getting a number, you're getting an age, so numerical, good. Sex or gender, what is that gonna be? You can just feel free to tell me.
Categorical.
Yeah, good, categorical, nice. All right, so only child?
Categorical.
Categorical, good. Height?
Numerical.
Good, numerical. Weight?
Numerical.
Good, numerical. Credit hours?
Numerical.
Good, GPA?
Numerical.
Numerical, good. And major?
Categorical.
Categorical, you got it. Nicely done. All right, so think about how you are going to tell the difference. Now, it seems pretty straightforward, but I'm going to throw you guys an example or a question, and I want you to tell me again, categorical or numerical, okay? Let me open the chat box and we'll do this. If it is categorical, say yeah, go, what's a good one? Thumbs up. If it's numerical, give me a wave. Okay, so my question is zip code. So if it's categorical, give me a thumbs up. If it is numerical, give me a wave. Zip code. Oh, not like with your hands, but like on the bottom. Give me a blue thumbs up or a blue wave. Zip code. Thumbs up for categorical. Give me a wave for numerical. Ooh, yeah, that one's a tough one, huh? I got a mix. Zip code. Still waiting for a few. Billy, Harry, Bernard, Lily. Still waiting for a few more. Oh, Lily, are you okay? You there? Oh. Okay, things might not be working. Harry, you got it? So Harry, I'm still not seeing your thumbs up or your wave. Okay, there we go.
I think I pressed it twice, both times.
Oh, okay, no worries, no worries. Okay, so we got a mix. That's a little tougher, right? Zip code, because a lot of times students will think, okay, zip code is a number, so it's numerical, but it's tricky. It's actually categorical. All right, so those of you guys with the thumbs up, good job. It's actually categorical. The reason why is because the zip code represents like a city, right? And so there's no like scale. It's not like 91109 is better or greater than 91108 when it comes to zip code. So because of that, it's actually categorical. So I think instead of determining if it's categorical versus numerical by is it a number or is it not a number, I think the best way and the easiest way to determine is if it's numerical, there are units, right? There's units of measurement, like age had, 21 years, height, inches, weight, pounds, okay? So there's units. When it comes to categorical, there are no units, right? What's your major? Science. There's no units behind it, right? Are you an only child? There's no units. So I think that is the best way to tell. Categorical, no units. Numerical, there are units. Does that make sense? Yeah, question.
I have a question. So when you say like categorical doesn't have units, do you mean like no increasing units? So like numerical would always have something like increasing, like age or measurements or whatnot?
I would say it doesn't have to be like increasing. It's just when you give a response, there's like a unit measurement behind it. Like if I asked you, like, yeah, how old are you? You would say like 17 or 18, I don't know, like 17 years, right? There's years, that's like the unit of measurement. Yeah, okay, sweet. Any other questions, categorical versus numerical? Okay, good job. Let's continue then. And under categorical and quantitative, there's actually like a differentiation within the numerical, which is a discrete numerical versus a continuous numerical. All right, so categorical is just categorical, but under numerical or quantitative, you can differentiate between discrete versus continuous. All right, so discrete variables can take one of a finite number of distinct outcomes. So if you were to, plot all the possible responses on a number line, it would be a bunch of dots. Versus continuous, it can take any numerical value within a certain range. So if you were to graph all the possible responses, it would be like a shaded region on a number line. All right, so isolated points versus a shaded region. All right, and I will give you guys a trick on how to distinguish between the two as well. But let's see if you can identify first with the same examples, just looking at the numerical, okay? All right, so age. What do you guys think about age? Does that seem more discrete or continuous? Would you plot it like little, like dots, or would it be like a shaded region on a number line? Any guesses? Discrete, continuous?
Discrete.
Yeah, good. Discrete. You got it, Madison. So yeah, this would be discrete. All right, so you would just see dots of like 1, 2, 3, 4, 5, and those would be isolated dots on a number line. So that is discrete. Good. What do you guys think about height? Discrete or continuous?
Discrete.
In this one, I would say height might be more continuous, just because if you're 5'2", or no, I'm 5'2" actually. You can be 5'2", you can be 5'2" and a quarter, you can be 5'2" and a third, you can be 5'2" and a half. And there's like, I would say it'd be a shaded region, anywhere from like, 0 height all the way to the tallest person. And you could be anything in between. So I would say that is continuous, would be continuous. Okay. What about weight? What do you guys think? Discrete or continuous?
Continuous.
Good, yes. Weight would be continuous. Nice, because you can be anything from 0 to like 500 pounds and everything in between. So it'd be a shaded region. Good. What about credit hours? Any guesses? Discrete or continuous? Ooh, okay. This is
Discrete.
Yes. Awesome. Yeah, discrete. All right, so these are, hours that you earn credits for. These are individuals. Okay. And GPA.
Continuous.
Oh, yes. Good job. All right. Continuous. Okay. So I have a trick for you guys. If that was a little more difficult or if you're not sure, discrete variables are typically variables that you can count, right? How old are you? You count how many years you have. Credit hours, you count how many credit hours you have. Continuous variables are typically measurements, all right? We measure height, we measure weight, we measure GPA, right? Or we calculate GPA. All right, so discrete typically counting, and continuous would be more measurements. Okay. All right, so let me go ahead and give you guys just a few more bonus examples. If I were to ask you how many pairs of jeans you own, what would you guys say, discrete or continuous?
Discrete.
Good, yes, discrete, nice. What if I asked how much or your head circumference?
Continuous.
Continuous, yeah, because you measure your head circumference. Good. All right. I think you guys got it. Any questions, or do you guys want more examples? Go ahead and say something if you want more examples or you have questions. Okay, awesome. So those are the vocab terms for today. Next, let's go ahead and move on to some graphs that you guys are probably familiar with, and some of you guys already did this with our activity last time. So, okay, got it. Here we go. All right. So the first graph, really it's a table. And if you want definitions, you can look into your textbook. But it's called a frequency and relative frequency distribution. All right. So frequency is just this one in the middle. And relative frequency is the one on the right. Pretty simple. Frequency is just you count how many are in each category. All right, so here there's 478 in category A. You just count how many there are. Relative frequency is talking about like the percent or the proportion. All right, so we have 478 in the A category, and we can tell that with frequency. Relative frequency, I can see that there's 19.1% of category A. 19.1%. Okay, who was that, Holly?
Sorry, that's my brother. He's
And Ray.
and someone else. They're coming to say hi.
Hi,
They didn't-
Ray.
Oh, yeah, she
I
says
know,
hi.
Ray. Hi, Ray.
She knows, Ray.
It turned out all right.
He turned out okay.
I don't know. He's wearing a Trojan shirt, so not that.
Oh, she didn't know about the Trojan shirt, Ray.
That was funny. All right, sorry. I got distracted. Okay, so frequency counts, relative frequency, proportion, or percents. All right, so I'm gonna have you guys practice this. So this is the frequency for survival rates when it came to the Titanic. All right, so you got first class, second class, third, and crew. These are the counts, and I want you guys to go ahead and tell me what are the frequencies, the relative frequencies, excuse me. What would the relative frequencies be? And I want you guys to put it in percents and round to the hundredths place. Okay, so go ahead and grab a calculator. If you don't have one around you, go ahead and find one. Or I'll let you use your phone if you can't find a calculator.
I'm gonna go get mine really quick.
Yeah, go for it.
Oh, that. Okay.
And I just gave all the answers. Okay. Actually, you know what? Since I already just showed all the answers, here you go. All right.
I'm really confused.
Oh,
I,
okay.
it's completely wrong. Can you like explain how you're supposed to do it? Because like I did it
Yeah.
wrong.
Totally. No, yeah, I actually realized I didn't really explain it, so that's my bad. So to get these relative frequencies, here are the answers. You guys can check. What you want to do is you want to add all the counts first, all the frequencies. So 325 plus 285 plus 706 plus 885. And then write that total down somewhere, like probably right underneath. You can say, this is the total. And then to find the relative frequency, you just do 325 divided by that total and write it as a percent. All right, for second class, you would do 285 divided by the total, and that would be your percent. Does that make more sense?
Okay, got it. Yeah. I just did it on the calculator with you. So yeah, thank you.
All
I have
right.
a question.
Yeah, question.
So, all my answers are like different than yours because I only have like 3 sig figs, but like when I add them together, they equal to like 100. So, do you have
Oh. Can you change your calculator to give you more sig figs?
Yeah, of course.
Okay.
But like I rounded to like 3. So.
Oh, okay. Because yeah, so in the directions, it says in percents to the hundredths place. So that's
Oh yeah. Okay. Cool.
yeah. So I'll be very specific with directions. That way, everybody has the same.
Okay. Gotcha.
All right. Good job. Okay. So that's frequency, which is counts, and then the relative frequency is percent. So if you're asked for relative frequency, go ahead and give those percents for that. All right. Any questions? Okay, let's go ahead to our next graph. Next one is bar charts, and you guys have already done this. So bar charts, I think you guys know already. Just know that bar charts are specifically for categorical variables, okay? Bar charts are only for categorical variables. There's another thing that looks like a bar chart for numerical, but that's called a histogram. So there's a difference between bar charts and histograms. So bar charts, categorical variables, and visually the difference is you guys will see these gaps between the bars, okay? So there are gaps between the bars when it comes to a bar chart. All right, and it's just really useful for like comparing different categories. The vertical axis will always be either frequency or relative frequency. All right, frequency or relative frequency. And this is a great graph because it stays true to what's known as the area principle, meaning that the areas are proportioned to the differences between each category, because the width of each of these rectangles is the same. So the only difference is the height, and that affects like the area. So the areas are proportionally visually different according to how these categories are different. Let me give you an example of one that doesn't stay true to the area principle. This Titanic ship graph, which looks great. I mean, that's fun. It has like these ships, but if you look at the difference between like, I don't know, like first and second on the bars, there's like not that big of a difference, but visually on the ship, it looks a lot more different because the area of the ship, or the length and the width of the ship is changing. So because of that, this is not a great graph. Even though it looks pretty, a bar chart is better because it stays true to that area principle. All right, so another thing that can go wrong with bar charts would be something like this. It looks great, it looks like the area principle is good, but if you look at the vertical axis, it starts at $55 instead of 0, which can be a little misleading because this looks like it's a huge jump. This looks like it's a huge jump, but actually the difference between $60 and $66, it's not that big of a jump. So having it start at 55 like this makes it just seem like it's exaggerating the differences. So that's another thing that you can be wary of when you look at articles and graphs and stuff. Okay, so yeah, that should start at 0. All right, so I think that, yeah, is bar charts. Any questions on bar charts? Okay, all right, our last graph, dot plots. All right, so a dot plot looks like this. This one's a vertical one. You can also do it horizontally. So you can just flip it so that the instead of a vertical axis, it's a horizontal axis. And I actually see that more often. I don't see vertical ones very often, but this one is. And a dot plot is just an easy, simple way to plot numerical data. All right, numerical data. This is talking about the Kentucky Derby. So each one of these dots is a horse and their winning time. And a dot plot's great. You can kind of see where everybody's lumped in. We have most people, not people, most horses between like 120 and 130, centered on the low end of the 120. And it's useful for small numerical data sets. You don't want to do this if you have like 2,000 horses. It's going to take you a long time to plot these. And at that point, the dots really, the individual dots don't really make a big difference because there's so many of them. So useful for small numerical data sets. I've sometimes seen it with categorical, so it's possible, but for the most part, we use it for numerical. All right, now if we were in class, we would make a dot plot where you guys would guess my age, but I don't think we are able to do that. Let me see how much time we have. Oh, it's okay. All right, there's probably a way to do it, but I think because of time, you guys will have to guess my age another time. Okay. All right. So that is our lesson for today. Just as a recap, you guys had vocab of univariate data set, bivariate data set, categorical variables, numerical or quantitative variables, discrete versus continuous, and then we have our graphs, right? Frequency and relative frequency tables, bar charts, and dot plots. Whew, we covered a lot today. All right, any questions on those? Okay, so what I'm gonna have you guys do, we are a little bit out of time, but you can get started on this. The second handout, that's kind of like a practice quiz for you, but just from today's lesson, just to practice today's lesson. It has a lot of the stuff we talked about. So go ahead and it's not homework, it's just practice. Go ahead and you can start practicing with that and ask me questions as you're practicing right now in our last kind of 4 minutes of class. You can start practicing. And I'm going to put the answer key up on Schoology for you guys to check it. Okay?
I have a question.
Yeah.
I was just wondering, so in your class for homework, is it always going to be due like the next day? Because I just know like last year, Mr. P's, everything was always due on Friday. So I was just like wondering.
Oh, yeah, no, mine's is just due the next day.
Okay.
Yeah.